Alright, in this video we're going to talk about percents of change. In prior videos we've talked about how to calculate percentages. In the last two videos we talked about how to calculate the whole number we were starting with percentages, or the piece, the is, or we're talking about finding the actual percent value. In this video we're just going to talk about when things change, how can we describe that change with a percentage. And that's the type of stuff we're going to do. So if you look at the first definition says a percent of change. It says it is a ratio that compares the change in quantity to the original amount. Remember, a ratio is just a fancy way of saying a fraction, okay? They're comparing two things to each other. Meaning they're going to be comparing how much it's changed to how much it started with. Now, if the original quantity has increased, it is a percent of increase. That's intuitive. Now, if the original quantity has decreased, percent of decrease. And of course, we're going to do examples of each of these. So let's first start off with this first example. In example 1, let's jump right in it, because this is, at this point, we know how to calculate percentages. It's a piece divided by the whole, or the is number divided by the whole, the of number. Sometimes we thought of that as. So that's what we're going to do. We're going to see how much compared to the original amount has it changed. That's what we're going to be doing. So in example 1, it says last year, 2,376 people attended the rodeo. This year, attendance was 2,950 people. What was the percent of change in attendance to the nearest whole percent? Because our answer is going to be a percent, don't worry about rounding to the nearest whole percent until the very, very end. You're not going to have to worry about any rounding until the end. So now, the first thing I want you to do is, if you look at the way they describe it down here, it says the percent of change equals the amount of change divided by the original amount. That is correct, the amount of change. But maybe you're a little unclear and you need a little more direction on what is that change. Maybe that's what you're trying to figure out. So now, if you're trying to do that, what I'm going to tell you is this, is a little more details. If we can describe that, we're going to write the exact same thing, but I'm going to give more description to the top. To find that change, you're going to do something like the final amount. I'm going to put AMT for amount, and then you're going to subtract the original amount, or the starting amount, wherever it came from. The original amount. Again, I'm going to use AMT. If you do that, and that can be the top of your fraction. If you did the final amount minus the original amount, that'll tell you how much changed. And that makes sense. Come on, guys. If we do 2950 and we subtract 2376, so that's 2,950 minus 2,376, it'll tell us clearly more people showed up. So we already know it's going to be an increase, but that'll tell us how much it increased. You're then going to, once you know the change number, you're then going to divide that by the original amount. So when you do these, you're going to see the original amount popping up more than once. Because you notice it's up top when we did final amount minus original amount. And then we divide. Remember, this is a big giant fraction bar. It means divide. Then we divide by the original amount. Because it's a percent of the original starting point. We don't want to know the percent of based on something else. But I'll show you that pitfall in just a moment. So in this example, if you subtract 2,950 people minus 2,376 people, you find out it changed by 574. Now, even if you subtracted those backwards, you would have negative 574, and you end up with a negative number at the end. But here's what I want you to know. Ignoring the negative for a moment, just use your brain. It went from this many people to this many people, to a larger amount. So clearly that's an increase. So if you accidentally subtracted these backwards and you have a negative number here, just use your common sense. You know it's an increase, so you'll just, so when you get to your final answer, ignore the negative if you had one, and just say it's a 24% increase, even if you actually had a negative sign. All right, well anyways, once you know how much it's changed by 574 people, divide that by the original amount. You've always got to divide by the original amount. It's always based off of where did it come from. Otherwise, the change doesn't make a difference, because if you describe change by where you ended up, that doesn't give you any perspective if you don't know where you came from. So it has to be based off of where you come from. And so in this example, if you do 574 divided by 2,376 with a calculator, of course, we're not expecting to do this by hand, you would get approximately, remember, the squiggle equal sign means kind of equal to, so approximately 0.24, and that equals 24%. And so that's how we know we had a percent of increase of 24%. We're going to be more specific than just saying a percent of change. We're going to be specific and say it was an actual percent of increase, because that way it's very clear to anyone who's observing or whoever you're communicating it to that it went up. As a side note, just to make sure you're rounding correctly, if you divided this, it approximately comes out to 0.24158. That is more than enough decimals places to show after the decimal. So just remember, when you're turning this into a percentage, to go from a decimal to a percent, as a reminder, if you don't remember this, remember your ABCs and then percents, QRS. Remember that percent, P for percent, is to the right of D for decimal. So anytime you're converting from a decimal to a percent, you're going to move your decimal place to the right, just like you would in the alphabet in order to go from D to P. So as a reminder, so that means this decimal place that's right here currently, we're going to move it over twice. So it's going to be after the 4. So that means as a percentage, that is 24.158%. And so it said round to the nearest whole percent, so I'm just reminding you guys how to round. Don't want to make it rounding errors. Go through all of this and make a rounding error. To round to the nearest whole percent, that means the ones position. So you look at the next position. This is called the tenths position. You look at this. It is 4 or lower, so that means round down, so that means it stays at 24. And that's why they said approximately 24%. And so once you see that that tells you to round down, you can just ignore the rest of it. All right, let's try a couple more examples. All right, if you take a look at example 2 at the top, it says, wow, I do not know what that name says. Che or Shay? We'll call it Shay. So anyways, Shay's grade on the first, didn't mean to move that. Shay's grade on the first math exam was a 94. His grade on the second math exam was an 86. I think you may have already noticed that he went down. Anyways, what was the percent of change in Shay's grade to the nearest whole percent? So we've already acknowledged and recognized that he went down because he went from a 94 to an 86. So regardless of whether you end up with a negative here or not, I want you to know, take a step back, use your common sense. You know he went down, so it's going to be a decrease. So when you find that percentage, it's going to be a percent of decrease. That's what I want you to focus on. All right, so just like earlier, we're going to do final amount, subtract the original amount. So he finished at an 86, and you subtract 94. Now, honestly, if you subtracted these backwards, it's not a big deal. That's why I mentioned it should be a negative answer here. You should do the final amount minus the original. So 86 minus 94, that'll give you a negative number. It gives you -8. But even if you just focus on finding the change, the fact that it went from 94 to 86. So even if you've done it backwards. So I'm just going to do it backwards, but I just want you to know it doesn't matter as long as you use your common sense when you're doing it. By common sense, I mean trust your gut when you know he went down. So if you did it that way, that would have given you +8 up top. That's an equal sign I'm squeezing in there. And then the original amount was 94. So for both of them, we're going to be dividing by 94. So -8 divided by 94. And then over here, 8 divided by 94. So now, regardless of which one of those you do, okay, you're going to end up with a negative if you do it in order, final amount minus original amount. You're going to get the negative, and the negative indicates a decrease. But even if you didn't, I just want you to know it doesn't have to be magic here. You can just say, I know he went down, so once you know your percentage, you're going to make it you're going to say decrease. Use the word decrease. All right, so anyways, 8 divided by 94. That's going to give us approximately, I'm going to put a few numbers out there just so we can review rounding as well, 0.8510. So now that should be enough to make a point. So now, we already said earlier, to convert from a decimal to a percentage, you got to move twice. So 1, 2. So that gives us 8.510. Now, it said round to the nearest whole percent again for this one. Because this is 5 or more, that tells us we've got to round this up to 9. And we could have done the same thing at this step way back here. We could have looked at this 5 and said, okay, we're going to make that 8 taller. But if you don't realize that once you're looking at the decimal, it's okay if you round after you convert it to a percentage. Does not matter. No big deal. So that's 5 or more, so we round up to 9. So that's going to give us 9%. And speaking of which, because this was a negative divided by a positive, this is a negative number. And so that makes this a negative number, and that makes this a negative number. So it's a negative percent. So we got negative 9%. Because it's negative, that indicates it was a percent of decrease. So we would say it decreased by 9%. Meaning 9% of 94, that's how much it went down by. That's what we would say from this information. Now, even if you had done it backwards over here, by backwards I just mean the order you subtract to the top, you would still get the exact same decimal, except now it would be positive 9%. So even though it looks like it was a positive change because it's positive over here, you're going to use your common sense and know chronologically it went from 94 to 86. Therefore, you're still going to write the word decrease. You're still going to say it decreased 9%. Same thing over here. You would still say decrease because you're going to use your common sense on that one. And that's what I mean. A lot of stuff doesn't have to be magic. Just trust your gut for a lot of these questions. So now for the next next 2 or 3 examples we do, I want you to hit pause and try them first on your own, and then hit play and see how you did, and see if you think you've fully got this. All right, so in these 2 examples, you'll notice they both have decimals in them, and they both also have units of measure. That way we keep having a little bit of perspective. So for each of these, it's going to be exactly the same, even though it's a decimal. I want you to do exactly the same, but all you got to do is just do your decimal operations like you normally would. So press pause and try both these questions, or just try one and then hit play and then try the other. And then we'll probably do 1 or 2 examples after these with some longer word problems. But take a moment and see how you do on these questions. Press pause for a moment. All right, so for each of them, just remember that the order it's going to be in. It's always going to, but the order is really not big of a deal. Just find the change. In the top right, I just remind you, remember it's change amount divided by original amount, or more accurately, we could say it's the final amount minus the original amount. That is your change number, and then divide that by your original amount. That's what we're gonna do for both of these. So let's see. It starts off at 0.55 minutes, or minutes, since that's less than a minute. It's not plural. And then it finishes at 0.1 minutes. So what we're gonna do is we got to use our place value skills here as well. We're going to do 0.1, and then we're going to subtract where we started from. So that's going to be 0.55. And then we're going to divide that change amount by the original amount. And the original amount we said was 0.55. Now, questions like this, they require you to use, this one's not only making you use your decimal skills, but you're also going to use your negative skills. So if that intimidates you in a question, remember, you can always do it in the other order. So for this question, you're more than welcome to do it in the opposite order. To do it in, let's say you wanted to avoid the negative, so you're going to do 0.55 and then subtract. So in other words, do the opposite. Do the beginning amount minus the ending amount. If that's going to help you avoid the negative. But just use your common sense at the end to know if it's not positive or negative like it should be. Make sure you still indicate whether it was a full-on change, percent of increase or decrease. So it's exactly the same up top. On bottom, but the top is just going to give us the same number. It's just going to have the opposite sign. Anyways, using your calculator or using your negative skills, whatever you choose to use, if you do this problem and you subtract 0.1 minus 0.55, you're going to get negative 0.45. You can get negative 0.45. We're going to divide that by 0.55, the original amount. And then when you divide that, that decimal is what you're then going to turn into a percentage, and then you're going to be done at that point. So in my calculator, 0.45 divided by 0.55. Okay, and that's going to be, it looks like a repeating decimal. So that decimal is coming out to, I'm going to have to round a little bit, so that's my squiggly equal sign. 0.818181. Now that's enough to make a point. So now let's convert that to a percentage. So 1, 2. Okay, so that tells us 81.81%. And now, based on the instructions, how to want us to round, it's never going to say round to like the thousandths way out here. That wouldn't be very practical. It's going to either say round to the nearest tenth, round to the nearest hundredths, or round to the nearest whole percent. So in this example, we'll go ahead and we'll round to the nearest whole percent. So the nearest whole percent is the ones position. So look at the tenths position. That is 5 or more, so it tells us to round up. So this one's going to round up to 82%. And we're going to use our brains for a moment, because you actually notice I forgot anyways. We said this was negative up here, so this decimal is negative, so this is negative, so now our answer is negative. So negative 82%. But if we use our brains, it went from 0.55, meaning 0.5, to 0.1, or you can think of this as 55 cents, and this is 10 cents, although we're talking time here, not money. But you know it went down. So you could just say an 82% decrease, or you're welcome to say a negative 82% decrease. Honestly, it's not that big of a deal, as long as you can indicate whether it was an increase or a decrease, and what percentage of the original amount did it increase or decrease by. So even if you had done it backwards over here, meaning the opposite order you divided them in, you're still going to get positive 0.45 over 0.55, and you would divide to get the exact same decimal, except yours wouldn't be negative, yours would be positive. But you would still need to use your common sense to be like, oh, it was a decrease, so I'm still going to say decrease of 82%. All right, so if you haven't already tried question number 4, press pause now and do so, and then check yourself. All right, so in this one, we're going to underline our starting amount, just so we're clear. I'm going to color code it, green for go, red for stop. So it started at 2.9 and finished at 4.9. So I'm going to go ahead and do 4.9 minus 2.9. And you're already going to notice, well, hey, it went up. So I'm expecting this to be a percent of increase question. So have your lifeguard perspective and be ready to report that you know it's going to be a percent of increase. So even if you had accidentally done it backwards or whatever. Now, in each of these questions, I want to mention, if you don't divide by the original amount down here, if you accidentally divided by, let's say, the finishing amount, you're going to get a completely different answer that's not going to be correct. So that's one of those things you don't have leniency with. When you divide on the bottom, it's change amount divided by original amount, you're going to get it wrong if you accidentally divide by the finishing amount instead of the original amount. You're going to get a completely different answer. So just be aware of that. We want to know the percent of increase or decrease based off of where did it start. So keep that in mind. All right, so anyways, we go to calculate this and see what this equals. Let's simplify. On the bottom, we know we're still going to have 2.9 months. And on the top, 4.9 minus 2.9, well, that's going to be 2. So that means the change is 2 months. So that was the change. 2 months went by. And now we just have to do 2 months divided by the original amount, the starting amount of 2.9. So with your calculators, you're going to do 2 divided by 2.9. Remember, it's top number divided by bottom number. And that gives you approximately, those are my squiggly equal signs, 0.6896, and that's enough digits. So it keeps going on, but I'm going to stop at that point because you don't need to keep going further. And now just remember, move the decimal place twice. So you end up with 68.96%. In this example, let's assume it was round to the nearest whole percent. Because this is 5 or larger, we round up in the tens place. So this is going to round to approximately 69%. And we know it was increased because it went from 2.9 to 4.9. So we're going to say 69% increase. And that's the core of that problem. So take a moment to check yourself. Then we're going to do maybe 2 more examples, but definitely 1 word problem. All right, we're going to call this question number 5. This question is about reading, and it says, in the 7th grade, Rachel read 15 books. In the 8th grade, she read 18 books. Find the percent of increase in the number of books that Rachel read. If you think you've got this question, even if you don't, at least hit pause. Give it a shot first on your own and see how you do. And I left you a few tips on the screen reminding you to change amount divided by the original amount. Hit pause. Try this one out. All right, so now it says that she started off at 15 books in the 7th grade, and then the next year she was at 18 books. So that means the original amount, the starting amount was 15, and then the finishing or the ending amount was 18. So now let's go ahead and subtract those. We're going to do 18 minus 15, and that's going to tell us how many books she went up by. Now I know these are small, simple numbers, so this one you already know, but we're going to go through the process anyways. So let's see, 18 minus 5, we know that's 3, and that's going to be over the original 15 books. So now you have 3 divided by 15. Well, 3 divided by 15, you can use your fraction skills if you want to turn that into 1/5, or you just divide at this point, do 3 divided by 15. So whatever you choose is up to you. So if you go ahead and just divide now, I'm not even rounding, this is an even decimal. So this is a precise answer, there's no rounding necessary. Comes out to 0.2. Now 0.2, got to turn that into a percentage. Move that decimal over twice to the right. Now you notice you have an empty space now when you moved it, so don't forget, that means you put a 0 here. So that becomes 20%. That's what that means. That means 20%. And we see that she clearly went up in her reading from 15 to 18. So that means a 20% increase in how much she read as compared to 7th grade. So we'd say a 20% increase. And that's all you need to do to find the percent of increase for this question. So take a moment to think about how you did with that one. We're going to do one more example, and then we're going to be all done. All right, this will be our last example, so go ahead and hit pause and see if you can do it on your own, and then hit play and check yourself. Give yourself some feedback. Make sure you're doing it correctly. All right, now in this question, we're going to go ahead and read it through, and we'll go ahead and, as we read it through, we'll mark down the information we need. It says, last year, 762 students voted in the student council election at San Bruno Middle School. This year, 721 students voted. What was the percent of change in the number of students that voted to the nearest tenth? So this one says round to the nearest tenth. Speaking of which, I didn't check. I don't recall if the last question told us how to round, but there was no rounding necessary, so I guess that's why I didn't mention it. So never mind. Afterthought. All right, so anyways, let's answer this question. Hit pause if you haven't done so already and try this question out. So we're going to do the final amount minus the original amount. So that's going to be 721 minus 762. Now, using your common sense, you see it went from 762 last year to 721. So it clearly went down. So you know it's going to be a decrease, a percent of decrease. So even if you do not subtract these in the correct order up here because you just don't feel like messing with the negative numbers, maybe you're doing it by hand. If that's the case, that's okay. I just want you to know at the very end, make sure that you indicate whether it's positive, negative, or not. Once you find that percentage of decrease, or that percent, just say that it is decreased because you realize it went down. Doesn't have to be magic here. All right, so anyways, you subtract these out, you're going to get negative 41. So that tells us it went down 41. And now we're going to divide that by the original starting amount of 762. So 41 divided by 762. It gives us a decimal that's approximately negative 0.0538, and it keeps going, but that's enough to make a point to go help us round and do our job. It says now that voted to the nearest tenth. So once we get our percentage, we're going to round that to the nearest tenth. So we'll move this decimal twice. So it goes after the 5, before the 3. So that tells us negative 5.380. Now it says round to the nearest tenth. Well, the tenth is the first number after the decimal. So you have to look at the next one, the hundredths, to tell you how to round the tenths. This one is 5 or higher, so that tells you to round up on this one. So that's going to come out to negative 5.4%. And that was a percent when we got that step. As soon as you move that decimal 2 places, it became a percent. So because it's negative, and even if you accidentally had it negative, you weren't sure, just use your brain for a moment. It clearly went down, so it's okay if you simply just say, if you didn't even have that negative sign, if you just said 5.4% decrease, that would be enough. Because you're saying, as compared to last school year, the amount of students voting went down by 5.4%, and that's what you want to know. That's your comparison quantity that allows you to make judgment calls and to share information with other stakeholders. A stakeholder is just someone who's interested in what's going on. All right, guys, so in all of these, just remember, it's the same percentage skills we know. It's the piece or the whole, the piece or the part divided by the whole, but in this case, the whole that we're comparing it to, the entire pie, is the original amount, because we care about how did it change compared to the original amount. That way we can track good changes, bad changes, based on what we're looking for. So change amount divided by original amount, and that's what you need to focus on. So practice these, and just make sure that you use your common sense when knowing, is it a percent of increase or a percent of decrease.